So, ladies and gentlemen, this is 5.3. First order of business is the bell ringer here. This should be a review of what we were working on before. Set everything equal to 0 by moving that 20 over. So we have numbers that multiply to be 20. We want them to add up to, I guess, 9 here. See what we end up with. So we had to be 12. 4 times 5. Yep, good thing because that was the last pair. So we have x plus times x plus. We're going to have to put 4 and 5. Set each one equal to 0 separately. So we're going to have x is negative 4 and x is negative 5. You should never get these wrong, because you could always plug them back in and just check. That's 16 minus 36, negative 20. Yeah, I put negative 5 in. Get 25 minus 45. Sure, that'll work. Okay, let's go ahead to number 2. Again, I'm going to set this equal to 0. I'm going to keep 16x squared right where it is. I'm going to subtract 8x over and add 1 over. 16 times 1 is 16, so I got 1 times 16, 2 times 8, 4 times 4. So 16x squared stays out in front, plus 1 stays on the caboose. So I'm rewriting these. My signs minus plus will give me minus minus when I factor. I want two numbers that multiply to be 16 and add up to 8. So clearly that's 4x and 4x. GCF of these two is 4x. So that leaves me with 4x minus 1. GCF here is negative 1. Leaves me with 4x minus 1. Again, what matches up inside parentheses? That's good, because if that didn't match, I did something wrong. So I pull out these 4x's minus 1. Leaves you with another 4x minus 1. So you can just set one of these 4x minus 1 equal to 0, because if you do both, you should recognize it's going to be the same thing. 4x equals 1, x is equal to 1 divided by 4, 1/4. This is a double root. Why do we say it's a double root? Because it's there how many times? Once, twice. Okay, so we are now finished with 1 and 2. Let's go ahead and jump into our essential question. How do we solve quadratic equations by finding square roots and use quadratic equations to solve real-life problems? Okay, so a little bit involved here. Okay, this one you shouldn't find too bad. We're going to break down radicals. Hopefully this is a review. Remember, you can't take the square root of a negative, so you can't take the square root of a 0 or a positive. That's what that's basically saying. So let's break down 50 now. When you break down radicals, the only numbers we care about are 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225. I'll stop it. The reason I put these up here is because these are all the numbers you can take the square root of. Like the square root of 4 is 2. The square root of this 9 is 3. The square root of 16 is 4. The square root of 25 is 5. Those are the numbers we want to make this into. So when you look at 50, 50 is not on here. But 25 goes into 50 twice. So I know 25 times 2 is 50. I then also know I have the square root of 25 times the square root of 2. The square root of 25 is 5, so I'm left with 5 root 2. Voila. Let's look at 54. Square root of 54. Well, 54 would fall in here. 49 doesn't go into it. 36 won't. 25 doesn't. 16. 16 and 16 make 32 plus 16 is 48. Close, but no cigar. 9 does go into it though. So I'm going to say this is 9 times 6. 9 times 6 is 54? Yeah. So this is 3 root 6. Double check to make sure 6 can't be broken down. The only number you need to check that's smaller than 6 is 4. Does 4 divide 6 evenly? It does not. It has a remainder. So you would stop at 3 root 6. Square root of 45. 45 is in here. That does not go into it. Does not. 16 does not go into 45. 9 does. This is 9 times 5. This is the square root of 9 times the square root of 5. So this is 3 square root of that number, 5. Square root of 9 is 3, so I have 3 times root 5. Number 4, square root of 40. That's here. No, 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 yes. Okay, so I can write this as the square root of 4 times the square root of 10, which is 40. And this is 2 square root of 10. 9 does not divide 10. 10 is not divisible by 4. Okay, because it will be 2.5. You want whole numbers when you divide. All right, let's take a look at 80. 80 would fall right here. He does not go into it. He does not. 36 is 72, so no. 75, nope. 16, there it is. Square root of 16 times 5, which is then the square root of 16 times the square root of 5. Break it apart. Square root of 16 is 4. 5 cannot be taken down. And that's that. 243. I'm wondering. 26, 15, 16 squared, no. 243, let's see, does 144 go in that? No. 121? No. 100, no. 81 absolutely does, though. Check it out. That's a hard one to see if you have a calculator. Go ahead and type in 243 divided by 81. 81 actually goes into that 3 times. If you do 3 times 81, you'll get 243. So we have the square root of 81 times the square root of 3. This is 9 square root of 3. Okay? There is all your radicals broken. Now, there are other rules that we'll talk about as we go down through here, as you see the quotient property of radicals. You're not allowed to keep radicals in the denominator. Okay? So these will probably be a little bit more work than the ones before, especially when they don't take the square root nicely. That list still stays the same over here. 4, 9, 16, 25, 36, 49, and, continue with that if you like. So we can basically say this. We can either choose to break down these in square roots, do this, which I don't want to do, or I can actually reduce my fraction before I do this. I can recognize these are both divisible by 2. So I'm going to make this 16 over 25. I am then going to make this the square root of 16 over the square root of 25, which we know that is 4 over 5. So if you know what you're looking at, life is going to be easier. So when you look at 2 here, can you reduce 1/9? No. So now we split it apart. Square root of 1, square root of 9. Square root of 1 is 1, square root of 9 is 3. Life is good. 1/3. Same thing here. 49 over 9 cannot be reduced. So we're going to break it apart. So this is going to be 7 over 3. Okay? Life is good. Remember, fractions are actually your friends, guys. Just be patient with them. So we're going to shift down here, and you can kind of see what this is leading us into. When we solve for x squared, you could always subtract 121 over and factor it, but it's a lot more efficient to do this. Just remember that you need a plus or minus. So this is plus or minus 11. Now, for those people that have a hard time seeing why you need a plus or minus, watch what happens here if I do it a different way. I would not suggest doing it this way. I'm going to set it equal to 0. I am then going to factor what I'm having here. Minus would be plus minus. I want the two numbers that multiply to be 121, but give me 0x in the middle. That would be 11. So x plus 11 equals 0. X minus 11 equals 0. So that one gives me a negative 11. This one gives me a positive 11. Thus, you can see that this is true. There's a positive 11 and a negative 11. There they are. Okay, potato, potato. It's the same deal. So when you do this next one, I would divide by 3. So I get x squared equals 36. I then take the square root, which is x is equal positive negative 6. Okay? Over here, subtract 1. 2x squared equals 16. Divided by 2. X squared equals 8. Square root. Plus or minus. This is 4 times the square root of 2. So my final solution is x is equal to positive negative 2 square root of 2. probably not like that one as much because it has everything kind of getting incorporated with it, breaking down the radical, taking the square root, and having two solutions. Okay? Looking at number 4. I'm going to add 12 over. It's going to be negative x squared plus 12. So that'll be 5, 75, divided by negative 1. So x squared equals 75. Square root, don't forget your plus or minus. 75 is 25 times 3. So this will be 5 square root of 3. Positive 5 root 3 and negative 5 root 3. You need both. Okay. And 5, I'm going to add 1 over. We get x squared over 25 equals 12. Multiply 25 over. If you have 12 quarters, how much money do you have? I believe that's $300. $3. Okay? So I'm going to take the square root of this, and it looks like plus or minus 100 times 3. What's the square root of 100, guys? Okay? And moving right along here. Oh, okay. Can't get a common denominator. You could also get rid of all your denominators by multiplying everything by, 6. I'm going to choose to get a common denominator. This is being multiplied by 2. Multiply that by 2. So we have, 5x squared minus 2x squared, so we have 3x squared. All over 6. I can reduce this to be x squared over 2. Multiply to be 2. X squared will equal 144. Don't forget your plus or minus, and square root of 144 is. So positive 12 and negative 12. There's 4, 5, 6. Alright, let's finish up here down at the bottom. Keep life simple, stupid. Let's get this 4 out of here. So I have x plus 1 squared equals 25. And then I'm going to take the square root. X plus 1 will equal positive negative 5. So, positive answer. X plus 1 equals 5. Negative answer. X plus 1 equals negative 5. So, if I subtract 1 here, x is 4. If I subtract 1 here, I'll get x is negative 6. Okay? Over here. Divide by 5. X minus 7 squared equals. That'll be 20. And I'll dip it to 35, so 27. We'll break down the square root of this. This isn't as nice as the one before. I don't need that square anymore. Technically, I don't need my plus. So, plus or minus, this will be the square root of 9 times 3. So this is x minus 7 equals positive negative 3 root 3. And I'm going to add 7 over. So my one answer is going to be 7 plus 3 square root of 3. And my other one's going to be 7 minus 3 square root of 3. So it's both of those. Okay? 7 plus 3, 3 root 3, and 7 minus 3. Right? And here we go. First order business. Let's get rid of that 45. So that's going to be 898. Second order of business. Divided by 2. I'm isolating the x minus 6 right now. Square root. Don't forget the plus or minus, because this will be positive negative 7. So then I have two scenarios. Here's my positive, x minus 6 equals 7. Here's my negative answer. So the x minus 6 equals negative 7. Okay, so add 6 to this, I'll get 13. Add 6 over here, I'll get negative 1. So both of these solutions will work in this guy. All right? If you have any more comments, questions, please email me. You know what to do. I'm just about out of time, so see you guys in class.